Okay, so in this video, we'll learn how to model data using logarithmic functions. So while exponential models describe rapid growth or decay, logarithmic functions are great for a different kind of pattern. One where there is a rapid initial increase followed by a slow rate of growth. So a common form of logarithmic form is f of x equals a plus b times ln x. So here a and b are constants and you have to make sure the b is greater than 0 for increasing functions, and ln represents natural logarithmic function. So this model is useful when data rises quickly at first, but then levels off over time. For example, like learning curves, diminishing returns, or cooling rates. So when you're using a calculator or a software to fit logarithmic models, you must make sure that all x values are positive. It's because the domain of logarithmic functions is always positive. So if your input includes zeros and negative numbers, so you'll need to shift or transform the data before you're applying that into your model. Okay, so let's try an example with this model. Okay, so here I have a table, and this table projects uh, the percent of US adults with diabetes. So this shows how the numbers increase dramatically. So first step is you have to find the logarithmic model that fits the data, and you have to make sure that the x values, you have to set x equals 0 for 2000. So 2010, then the x value will be 10. So let me write the x values over here. So your input is going to be 0 because you take 0 for 2000. So this is 2010, which means your x values over here is 10. And then for 2015, it's 15. This is going to be 20, 25, 30, 35, 40, 45, and 50. So you have to enter this data into your calculator. So remember, your x value should be this. These are the x values, and you have to take the percent, which is this, as the y values in a graphing calculator, and you can use your stat and calc linear regression in logarithmic uh, function statistic regressions in your calculator, and you can model this data. So if you model this data, you'll get this function. So I'll give you the answer. It's going to be y equals negative 12,975 plus 11.851 ln x. So here, remember, x represents the number of years after 2000. Okay, moving on to the second part. So now you have to use the reported model to predict the percent of US adults with diabetes in 2027. So to evaluate this, you have to plug x equals 27. It's because we usually take x equals 0 for 2000. That means in 2027 means x is equals to 27. So if you plug 27 into this model, you'll get something like this. So same function, but here instead of ln x, you have to evaluate ln 27. So now you have to simplify this. So to simplify this, you can use your calculator. And if you simplify this, you'll get the number as 26.1. So this is an approximated percent for 2027. Okay, moving on to the third part. So in what year does this model predict the percent to be 26.9? So that means you have to set y equals 26.9. So let's rewrite our model. 26.9 is equals to negative 12.975 plus 11.851 ln x. Okay, so now you have a logarithmic equation. So you have to solve this logarithmic equation. Okay, so the first step would be to move all constants to one side. So on this side, I have my natural logarithmic term as well as a constant. So I'm going to move that to the other side. To do that, I'm going to add 12.975 to both sides. So I'm going to add this number to both, so that way I can cancel out these two numbers. But on this side, it's going to be 39.875 equals 11.851 ln x. Okay, so now I need to isolate this term. So to do that, I'm going to divide both sides by 11.851. Okay, so here I go. I'm going to divide both sides by this number, which will make these two terms disappear. And here the ln x will be equals to 3.3647. Okay, so now you can rewrite this as a power function. That's going to be x equals e to the power 3.3647. And you can use this number using calculator. It's going to be 28.9. So that means, so in year 28, I mean approximately in 2029, the model predict the percent to be 26.9.